Hi there, and welcome to lesson 1.4 and 1.5. So today we're going to switch gears just a little bit, and we're going to now talk about angles. So we've been learning about segments and rays and lines. Now we're going to use some of that information and learn about angles. And similarly, just like we've been doing this week, most of this information is going to be review for you, but we're going to take it one step further. So you're either going to be given the definition and learn how to represent that mathematically, or vice versa. In some cases, we're going to have a mathematical representation and then come up with a formal definition of that term. So first, let's go ahead and jump right into angles. So what is an angle? Before we learn how to name it, we need to know what that angle is. By definition, an angle consists of two different rays that have the same initial point. The rays are the sides of the angle, and the initial point is the vertex of the angle. Okay, so that is our formal definition of an angle. So now let's take this definition and construct an example of an angle. Here we go. So we have this angle right here, and if we break down this definition, we see that it consists of two different rays that have the same initial point. So here we go. We have ray AC is going in this direction here, and we have ray AB that's going in this direction here. They both have the initial point of A. So we can see that this, by definition, shows the mathematical representation of an angle. And furthermore, we know that these rays right here are the sides. And point A, which is our initial point, is the vertex. So here is our mathematical definition or representation of an angle. Okay, now that we know what an angle is, let's go ahead and figure out how do we actually name this angle? And how do we measure it? So by measuring an angle, we measure an angle in what's called degrees. So lengths, segments we could do in centimeters, meters, inches, feet, miles, things like that. Angles we're going to measure in units called degrees. And the way that we represent that is this symbol right here. So this represents the measure of angle A. So I just called this angle angle A. How did I come up with that name? Well, naming an angle, we always use the vertex, no matter what. Now we can use more than just the vertex, but the vertex has to be used. And remember, the vertex is your initial point of those two rays. So we called this angle angle A. But we can also name an angle by using the sides as well as the vertex. If we do that, the vertex has to be in the middle. So we have a couple of other names for this angle. We can write this angle as angle BAC, as we see right here. So we would start with this point on the ray, B, and then our vertex, A, and then the third point on the second ray, C. Or we could go in the other direction and name it as angle CAB. Or, as we saw when we had up here in this example, we could also name this particular angle just by its vertex. We can use the vertex alone when there's only one angle that shares that vertex. If there's more than one angle, then we can't name it by the vertex. We have to use two additional points, one on each side. So one last thing before we move on to the next slide is we're going to just summarize here. We have an angle with sides AB and AC. We see that the vertex is point A. We can write this angle as angle BAC, angle CAB, or angle A. All right, let's go ahead and move on now. So now we're going to go on to another postulate. This is very similar to our ruler postulate. And this postulate says that two rays that share a common endpoint can be matched 1-to-1 with real numbers from 0 to 180. The measure of the angle is equal to the absolute value of the difference between the real numbers of each ray. Okay, again, just like our segment addition postulate, this has a lot of words. What this is saying is that we can simply measure an angle by placing its vertex in the center of the protractor, lining up the sides, and subtracting the two numbers to get that angle measure. So let's have an example here. We have ray AB is lined up with 0 degrees. Here's our 0 degrees right here. And we can see all these numbers here. And ray AC is matched up with 45. If we take a look right here, we see that this is halfway between 40 and 50. So now we can find the measure of angle BAC, which is this angle right here, by subtracting these two numbers, 45 degrees minus 0 degrees, which gives us the measure of angle BAC is 45 degrees. Now we have another angle that we can measure, which is angle CAD. So here we have ray AD is matched up with 180 degrees if we use the outer numbers. And we already know that AC is matched up with 45. So to find the measure of angle CAD, which is this angle, we're going to take 180 minus 45 to get our angle measure, and the measure of angle CAD is 135 degrees. So that's how you use a protractor to actually find the measure of an angle. All right, let's go ahead and move on to the next slide. So now we're going to classify angles, and I know that you're familiar with these definitions. You've seen them before in your previous classes. But we're going to take it again one step further, where you're either going to come up with the definition or the mathematical representation. So first things first, an acute angle. Mathematically, an acute angle measures between 0 and 90 degrees. So this is how we represent it mathematically with our less than sign. So 0 degrees is less than the measure of angle A, which is less than the 90 degrees. And here's our angle A right here. It's an acute angle. So the written definition, or the formal definition of that, would say an angle is acute if its measure is between 0 and 90 degrees. Okay, I'm going to fly through these next ones pretty quickly, and you can pause the slide here if you need to write things down. So our next one is the right angle. A right angle, mathematically, means that the measure of the angle is equal to 90 degrees. Okay, now go ahead and pause the video. I want you to write down the formal definition of what a right angle is. Okay, so hopefully you paused the video. Now we're going to go on to an obtuse angle. An obtuse angle, mathematically, means that its measure is in between 90 and 180 degrees. So 90 degrees is less than the measure of angle C, which is less than 180 degrees. So here is our obtuse angle right here. It has a measure between 90 degrees and 180 degrees. Now go ahead and try and write the formal definition of an obtuse angle. Okay, moving on to the straight angle. By definition, a straight angle is an angle that measures exactly 180 degrees. So an angle is straight if its measure is exactly 180 degrees. Now, we've given the formal definition, and here's what a straight angle looks like. I want you to write mathematically what that means, and I will give you a hint. It's going to be similar to what a right angle is. So now you can kind of check different definitions and see if you have the wording the same or the mathematical representation the same. All right, let's move on to the next slide. So we have the angle addition postulate. This is similar to the segment addition postulate, which says that basically if we have two angles that have a common ray or a common side, just like this one does right here. So we have two angles here that share side AD. Then we can add the two angles together to get the measure of the larger angle. So if we were to add angle BAD, which is this angle right here, and angle DAC, which is this angle right here, together we would have the measure of this big angle here, which is angle BAC. So now let's go through an example. So we have an angle here that's made up of two smaller angles. So we have angle QRT and angle TRS. These two angles make up this big angle QRS, we are told that the measure of angle QRT is 40 degrees. So this small little angle here is 40 degrees, and TRS is 83 degrees. We can now find the measure of the larger angle QRS by adding the two together, 40 plus 83, which equals 123 degrees. We now have used the angle addition postulate to find the measure of angle QRS. Pretty basic. Okay, moving on. So we're going to go into a couple additional angle terms. So if we have two angles that have the same measure, those are called congruent angles, just like we had congruent segments before. So if the two angles both have a measure of 60 degrees, then we know that angle BAC and angle DEF are congruent to each other. And the symbol that we use for congruency is the same exact symbol that we used for segments, right there. Next are adjacent angles. So if two angles are adjacent, that means they share a common vertex and side. So they would have both the same vertex in common as well as a side in common. So we see here angle A, which is right here, and angle B, which is right here, they both share this side right here. I'm sorry, that line was a little bit squiggly. They share that same exact side, so they are adjacent angles. Now, for example, if we had an angle here, and let's say we have an angle down here. These two angles are not adjacent. They do have a common vertex, but they don't share a side. This side right here is not in common with any side that this angle has. And similarly, this side over here is not in common with either of these two sides. So these are not adjacent angles here. All right, let's go ahead and move on. Okay, we're going to jump into one last thing before we move on to lesson 1.5, and that is angle bisectors. So angle bisectors are similar to a midpoint in that they divide an angle into two congruent smaller angles. So we have the following information. Ray AB bisects angle CAD. Given the information below, what are the measures of angles DAB and CAB? And first, let's make sure we know what angles we're talking about. DAB is going to be this angle right here, this smaller angle, and CAB is the other angle that is the same measure. So we have that the measures of the two congruent angles are x plus 40, so let's go ahead and label that x plus 40, and 3x minus 20. We need to solve for x in order to find the actual measures of the angle. Well, being that we know that these are congruent, we can set them equal to each other. So we have x plus 40 equals 3x minus 20. Now we're just into an algebra problem. Let's go ahead and solve. Combine like terms. So we're going to add 20 to both sides, and we're going to subtract x from both sides. So we get 60 equals 2x, divide both sides by 2, x equals 30. Okay, so now that we have this information, we can plug it into either one of these and find the measure of the angles. So we are going to plug it in. Let's go ahead and plug it into x plus 40. So we know x is 30, so we have 30 plus 40. That's going to give us the measure of angle CAB. So we now know that 70 degrees equals the measure of angle CAB. And since they're congruent, it's congruent to measure of angle DAB, we also know that that equals the measure of angle DAB. So now you've used information about a bisector to solve a mathematical problem. All right, let's go ahead and move on to lesson 1.5 now. So lesson 1.5, this is going to be a pretty short lesson. We're going to learn how to describe angle pair relationships. All right, so first things first, we learned in lesson 1.4 what a right angle is. By definition, it's a measure of an angle that's equal to 90 degrees. So, given the diagram below, or I'm sorry, to the side, we have all of these different angles. Angle 1 is going to be a right angle. And usually the way that we denote that that's a right angle is we put a box right here. And then you know if it has that box on the angle, this means that that's 90 degrees. Okay, our next angles that we're going to look at are complementary angles. Complementary angles are two angles whose measure have the sum of 90 degrees. The sum of the measures of an angle and its complement is 90 degrees. So for example, angles 2 and angles 3, those are complementary angles because we know that they will equal 90 since we have this straight line and we already know that this is 90 here. So angle 2 and angle 3 are complementary angles. Now, one thing that we don't necessarily know right now, but we'll learn later why this is the case, we could have also said angle 5 and angle 2 are complementary. And that's because we're going to learn that angles 3 and angle 5 have the same measure. So complementary angles don't necessarily have to be adjacent angles. They just have to be two angles that add up to 90 degrees. Okay, let's move on to the next one. An acute angle we know is an angle whose measure is between 0 and 90 degrees. We actually have lots of different angles on this diagram that we could have. Angle 5, for example, is definitely less than 90 degrees. We could have also said angle 2. That would be an angle that's an acute angle, or even angle 3. Any one of those would be acute angles. And we're just identifying these by picture. Okay, next one is an obtuse angle, which we know is an angle whose measure is between 90 and 180 degrees. Now looking at this diagram, there is only one angle that fits that bucket, and that's angle 4. Its measure is greater than 90, but it is not a straight angle, so it's less than 180 degrees. Now we're going to go into supplementary angles. Supplementary angles are very similar to complementary angles. It's just their measure is going to add up to their two angles whose measure is 180 degrees instead of 90. And take note, complementary and supplementary angles can only be two angles. So those two angles, not three, have to add up to whatever measure it is. So an example of two supplementary angles here would be angles 4 and angles 5. Can you find another pair of supplementary angles? Angles 3 and angles 4. Those would also be supplementary angles. All right, we also have linear pairs. Linear pairs are a special type of supplementary angles. And in fact, all linear pair angles are supplementary angles. Because linear pair angles are two adjacent angles whose non-common sides are opposite rays. And remember, opposite rays form a straight line. So all linear pair angles are going to be supplementary because they form a straight angle, and therefore by definition their sum is 180 degrees. Now, not all supplementary angles are linear pair angles. Linear pair angles have to be adjacent. That is part of their definition. They have to be adjacent here. So the two pairs of supplementary angles that we happen to have in this diagram are both linear pairs as well. But let's say we had an angle here, and let's say we had another angle here. And we'll call this angle A and angle B. If angle A and angle B add up to 180, we know that they're supplementary angles, but they would not be linear pair because they do not have a common vertex. And therefore they are not linear pair angles. So hopefully you see the distinction between those two. All right, let's move on to the next slide. Vertical angles. Vertical angles are two angles whose sides form opposite rays. Now remember again, we keep seeing this opposite ray. Opposite rays just mean a straight line. So we want two angles whose sides form two pairs, oops, sorry, that should say pairs, of opposite rays. So we have one pair of opposite rays right here and one pair of opposite rays right here. Angles 3 and angle 5 are vertical angles. And I'll show that here with the coloring. So vertical angles are going to be formed by the intersection of two lines. And they are going to be the angles that are opposite of each other. Angle 3 and angle 5 are vertical angles. And then we have adjacent angles. We already saw the definition of adjacent angles earlier. And those are two angles that share a common vertex and a side. So note, vertical angles will not ever have a common side. Whereas adjacent angles always will have a common side. Always. So an example of adjacent angles here could be angles 1 and 2. There are lots of different adjacent angles that we can have here. We could have said angles 2 and angle 3. Or angle 3 and angle 4. There are additional angles. One thing we can't say is angle 1 and angle 4. Those are not adjacent angles because they don't share a common side. So hopefully you can see the difference between adjacent angles and vertical angles. Okay, so we are going to end the lesson there. I know this was a lot of terminology and definitions, but in class you're going to get lots of time to put these definitions into practice and see how you can do some math with them. All right, well I hope you enjoyed this. It's a little bit lengthier of a lesson than I like, but hopefully you enjoyed this flipped lesson and look forward to seeing you in class. Have a good one. Take care.